Bismillahirrahmanirrahim. Today we are going to talk about neurotransmitter classification. This is the class number 2, and the class number 1 we have already defined the synthesis of neurotransmitter, axonal flow, release, uh, action of the neurotransmitter, and the reuptake of the neurotransmitter. But in this class, I will explain the only the classification of neurotransmitter. Neurotransmitter are mainly classified into two branches on the basis of action in the nature. What is mean by the action? Action mean neurotransmitter doing two. There are two types of neurotransmitter. One is excitatory neurotransmitter and another is inhibitory neurotransmitter. One cause excitation and the other cause inhibition. Okay, so this is on the basis of nature. As we know that from my previous classes, that from the class number 1, that neurotransmitter as a chemical messenger which carry impulse message from one neuron to another neuron or to the muscle cells or to the target gland cell. One neurotransmitter carry message from one neuron to another neuron or to the muscle cell or to the gland cell. Okay, as we know that message are of two types. One is the inhibitory message and another is the excitatory message. What is mean by the excitatory message? Suppose this is a neuron. When I touch this area, then the messenger is go from this area to this area. So they release excitatory. Suppose they release excitatory neurotransmitter. This neurotransmitter when released at this site, this neurotransmitter is said to this neuron to be excited. So when this neurotransmitter is released from this point and attached to the this neuron, so there will produce impulse in this neuron. So this is the excitatory neurotransmitter because it produce action potential. It excite another neuron, the other gland cell or other muscle cell. Okay, but in case of inhibitory neurotransmitter, when this neurotransmitter is released, it attached to this point and inhibit and prevent the forward grow of the message. So this is the inhibitory neurotransmitter. Excitatory neurotransmitter have its own importance in the body, while inhibitory neurotransmitter have its own importance in the body. So what is excitatory neurotransmitter? Excitatory neurotransmitter is a chemical messenger, is that type of the neurotransmitter which carry impulse from one neuron to another neuron, gland cell or muscle cell. Okay, this neurotransmitter is released by the presynaptic neuron and excite the other target cell. Okay, there are two confusable words, two basic concept. Excitatory neurotransmitter cause action potential in the target cell, while the inhibitory neurotransmitter inhibition cause inhibition post in the postsynaptic neuron or the target cell. Okay, how this phenomena occur? What is mean by the production of action potential? What is mean by the production of action potential? By the production of excitation and this target neuron. Okay, so let's come. As we know that when we touch this area, then the message go from this point up to this point, then it release the excited neurotransmitter and excite this area, and the message is produced in this another target. So, okay, how this phenomenon occur? Suppose this I zoom this area. Suppose this is that zooming dendrite ending. As we know that from my previous class, the action potential. This is I have already defined in a big detail the action potential in a previous class. Okay, as we know that from my previous class, and the resting state and the unstimulated. This is the resting state. Resting means unstimulated. Unstimulated state. Inside of the neuron is negative while outside is positive. This state is called polarized. Polarized state because inside is a negative charge while outside is positive charge. So this is the cell membrane of the excitable cell. Okay, this is inside of the cell, this is outside of the cell. Okay. when we touch this area, suppose when we touch this area by a adequate strength, then some conformational change occur in this area. Here, sodium voltage regulated channel open, so there are present and plenty of sodium, there are present plenty of potassium. As you know that from my previous lecture, that cell is a bag of the potassium. Cell have more number of potassium inside, while sodium is in more concentration outside. Okay, so when I touch this area, this positive charge due to sodium and this negative charge due to potassium. Okay, as you clear this concept from my previous lecture, when I touch this area, then sodium regulated channel open and sodium rush, plenty of sodium rush inside. So the polarized state is changed into depolarized state. Here, polarized state change into depolarized state. Okay, so the direction of the current inside, when large amount of sodium go inward, then potassium start go outward, so the direction of the current outside, so the action potential move in the forward direction. Okay, there occur some phenomena. Polarized state is changed into depolarized state. So and the excitatory neurotransmitter, when the action potential is reached here, when the action potential is go from this area and reached here, so when the action potential is reached here, then it stimulates this area and there calcium regulated channel open and the calcium go inside. When calcium go inside, this calcium is attached to the membrane of the vesicle. What is vesicle? As you know that this is the synaptic terminal. The synaptic terminal have a button-like shape which is called synaptic knob. This is the synaptic knob. Synaptic knob consists many of the vesicle which is called synaptic vesicle. This is the synaptic vesicle, and the synaptic vesicle contain thousands of the neurotransmitter. So calcium is attached to this area, to this membrane, and there are conformational changes and the membrane of the synaptic vesicle, and the synaptic vesicle is attached to is piezo with the cell membrane of the presynaptic neuron. This is the cell membrane of the presynaptic neuron. This is the cell membrane of the postsynaptic neuron. And here neurotransmitter is released, which is called excitatory neurotransmitter. When excitatory neurotransmitter is released here, then this neurotransmitter is attached to its own receptor on the postsynaptic neuron membrane. Okay. When excitatory neurotransmitter is attached here, same phenomena occur here. When excitatory neurotransmitter is attached here, same phenomena occur. Sodium voltage gated channel open and potassium voltage gated channel as open. So sodium influx, potassium outflux, and so the current is produced in the forward direction. So excited neurotransmitter do something. When excited neurotransmitter is attached here at open, the sodium voltage and regulated voltage and sodium and potassium voltage regulated channel. When this channel open, sodium go inward, potassium go outward, so the action potential produced in the forward direction. Because it produce, the main thing to be highlighted is that it cause depolarization. Because when the neurotransmitter is not attached to this area is inside negative while outside is positive. So this is the polarized state. Polarized state. When neurotransmitter is attached here, it causes depolarization and action potential is produced. So okay, so excitatory neurotransmitter is the neurotransmitter which cause action potential in the target cell. It produce depolarization in the target cell. So message is transferred in the forward direction. Okay. What is inhibitory neurotransmitter? What is mean by the inhibitory neurotransmitter? Inhibitory neurotransmitter is that type of the neurotransmitter which cause inhibition on the target cell. Suppose this is the inhibition. This is inhibition phenomena. So when we touch this area, action potential is go from this area and to this area, and suppose their release inhibitory neurotransmitter. When inhibitory neurotransmitter is released here, inhibitory neurotransmitter doing something. Inhibitory neurotransmitter when attached to this area, I suppose this area, this is the inhibition phenomena. Okay, so suppose this is the inhibitory neurotransmitter, and when it release, it cause hyperpolarization. It cause hyperpolarization, and the excitatory neurotransmitter depolarization is occur, while the inhibitory neurotransmitter, this phenomena, hyperpolarization occur and inhibit the target cell. How this phenomena occur? So when inhibitory neurotransmitter is attached there at its own receptor, then it cause to open only the potassium voltage regulated channel, and the excitatory neurotransmitter, uh, there are often two channels. This is the excitatory, and the excitatory phenomena, sodium voltage regulated channel open and potassium voltage regulated channel open. So sodium go inward from outside and potassium is go outward from inside. So action potential is produced in the forward direction. But in this case, sodium voltage regulated channel does not open. It remains in its closed form, while plenty of the potassium voltage regulated channel open and potassium go outward. So it causes hyperpolarization. As you know that from the action potential class, hyperpolarization produced in the neuron due to the outflux of the uh, polarization is produced by the positive and negative charge difference. So the hyperpolarization is produced, or hyperpolarization or polarization is produced by the outflux of potassium, while the depolarization is produced by the influx of the sodium. So when their hyperpolarization is produced, only potassium go outward. When hyperpolarization is produced, the action potential is not go in the forward direction. So this phenomena has its own importance in the body. How they have its own importance? Suppose this is the reflex action. You can clear reflex action in a big detail from my previous class. Okay, so this is a little bit concept. As we know that reflex action is an action of the body, and this is the reflex action is a quick response of the body to a stimulus. It does not involve the brain, as you know that from my previous class. It does not involve the brain, but it involves only the spinal cord. Okay, so during reflex action, both phenomena occur. Excitatory phenomena is also occur, and inhibitory phenomena is also occur. As we know that in a reflex action, when I touch this area, this is the tendon, then the knee jerk in the forward direction. Or when I touch this area by a needle, by some needle, or when I touch this area by some hard object. So the knee is forward, the knee is jerk in the forward direction, or when I touch this tendon, this quadricep tendon, then the knee jerk occur in the forward direction. For the knee jerk, there are two muscle. This quadricep muscle is to be contract, and this hamstring muscle is to be relaxed. So this is the two muscle which help in the knee jerk. It is need to be contract and it is need to be relaxed. So how this phenomena occur? When I touch this area, then the action potential is grow from this tendon to the spinal cord by the sensory neuron. So this is the sensory neuron. This is the cell body of the sensory neuron. The sensory neuron is divided into some branches. This is one branch. This is another branch. This is another branch. So this branch release excitatory neurotransmitter. Suppose this is the glutamate. It release suppose glutamate. When glutamate is released, this is the enter neuron. Enter neuron is stimulated here. Then the enter neuron again release two types of neurotransmitter. This part release excitatory neurotransmitter, while this part release inhibitory neurotransmitter. This is the enter neuron which receive message from the uh, sensory neuron. Then this part of the enter neuron release inhibitory neurotransmitter, while this part release excitatory neurotransmitter. Suppose this part release glutamic acid or glutamate, and this part release glycine. Glycine. Glycine is the inhibitory neurotransmitter. So the action when this part release excitatory neurotransmitter, action potential is produced here and stimulate this effector, this quadricep muscle, and this muscle is to contract. While it releases inhibitory neurotransmitter, it does not produce action potential in this neuron. So this is the motor neuron. This is also the motor neuron. So this new motor neuron is remain to be inhibited, and so this muscle cannot be contracted. It remain in its relaxed state. So when this muscle contract and this relax, knee jerk occur in the forward direction. When we touch this area, and the opposite direction when we touch this area by a needle. So for the prevention of the body from the injury, we need to be contract to be move our leg in the backward direction. When we touch this area by a needle, by a hard object, by a burning object, then we need to move my leg in the backward direction. So the message is go, and this muscle and the message is go, the phenomena is opposite. This part release, there are some different many number of the the enter neuron. So the phenomena occur in opposite. This muscle is to be contract, relax, and this muscle is to be contract. So we move our knee in the backward direction. So this is the preventative phenomena. Okay. So this is the importance of inhibitory neurotransmitter. Inhibitory neurotransmitter are dopamine, dopamine number one, number two, serotonin, glycine, and GABA. What is mean by GABA? GABA mean gamma amino butyric acid. So these are the inhibitory neurotransmitter. These are the main inhibitory neurotransmitter. While the excitatory neurotransmitter, for the excitatory neurotransmitter, a simple formula must be reminded. Hanga, Hanga, hanga. This is a simple formula. Hanga. What is mean by H? Histamine. What does mean by A? Acetyl choline. Acetyl Tyl acetyl choline. What is mean by N? Nitric acid. What is mean by G? Glutamic. Here is the glutamic acid, and here is the glycine. Glutamic acid. And what is mean by A? Aspartic acid. Aspartic acid. Okay, so this is the these are the excitatory neurotransmitters. This is a simple understanding formula. Hanga. Okay. Classification on the basis of the nature. The nature mean uh, what is the composition of the neurotransmitter. Okay, so on the basis of nature, we classify neurotransmitter into three class. Number one, amino acid. Number two, amino acid, like glutamic acid, aspartic acid, glycine. These are the amino acid. So this is the simple amino acid. Okay, so GABA, aspartic acid. These are neurotransmitter which belong to the amino acid. So these are the amino acid neurotransmitter. Another is amine. Amine mean What is amine? Amine is a modified amino acid. Suppose tyrosine. Tyrosine when passed by multiple up chemical changes, so it convert it produce three types of hormone, three types of hormone, three types of neurotransmitter: adrenaline, adrenaline, noradrenaline, and dopamine. So amine, amine or amide, simply amide, amide, amide. Okay. Amide are the, what is amide? Amide is the modified amino acid. When this tyrosine, say this is a simple tyrosine amino acid, is modified by some chemical reaction, it convert into adrenaline, noradrenaline, and dopamine. So adrenaline, noradrenaline, and dopamine are the amide. So another class of neurotransmitter is the amide. Third class is the other substance. These are the substance which are not amino acid nor amide, but this is the mixture. This is the mixture of the neurotransmitter. Suppose acetylcholine, ACH acetylcholine, and nitric acid. Nitric acid is a gas. Nitric acid is a gas. Gases neurotransmitter, while acetylcholine is also a neurotransmitter which is not an amino acid nor amide. Okay, so these are the nature of the neurotransmitter. Okay.